This is a mini lesson on naming and writing formulas of molecular compounds. Molecular compounds are made up of nonmetals. So these are the metals that are located to the right of the staircase line on your periodic table. The smallest piece we call a molecule. They cannot be held together because of opposite charges like we saw in ionic compounds, because there aren't any opposite charges here. They are only made up of nonmetals. So we don't have the cation and the anion, and the cation giving up electrons to the anion. None of that happens on molecular compounds because all of the substances that are involved are just nonmetals. So we cannot use any charges to figure out how many of each type of atom are in the compound. They may be solid or liquid or gas at room temperature, unlike ionic compounds, which are all solid at room temperature. A little rule of thumb that we can use here is that if the subscripts tend to be small, they're likely to be gases, and as they get larger, liquids and then solids. That's just a little guideline to help you. There's no hard and fast rule, though. The atoms in a molecule are joined together by covalent bonds. These form when atoms share electrons. Electrons are not transferred from one atom to another as they were in ionic compounds, but in covalent bonds, they share electrons to fill their outer energy levels and to become more stable. The naming is easier. In ionic compounds, if you remember, we had to use charges to help us figure out how to name and write formulas. In molecular compounds, the name itself will tell us. We use prefixes to help us, and so the prefixes will tell us how many of each type of atom are involved in the compound. These are the prefixes here. Again, they are in your data booklet, so you do not need to memorize them. And to write the name, it's pretty straightforward. You just write two words. You write the prefix and the name of the first element, followed by the prefix and the name of the second element, and the second element only ends in IDE. One exception is that we don't write mono if there's only one of the first element, and I'll explain that in a minute, and we omit the double O in monoxide. Okay, so for example, with the gas you're probably aware of, carbon monoxide, we do not call it carbon monoxide. Okay, let's go through some of these examples. N2O, so N is nitrogen. The subscript 2, we use the prefix di, so it becomes dinitrogen. And on the oxide, there's no subscript, so it's just implied that it's 1. So it's monoxide. In a second example, if you notice, there is no subscript on the nitrogen, so there is only one of that first element. We do not write mono when that happens, so we just call it nitrogen dioxide. The next example, Cl2, so that's dichlorine. O7 is heptaoxide. CBr4 is carbon tetrabromide. Again, remember, we do not call it monocarbon, it's just carbon tetrabromide. And then a familiar example, CO2 is carbon dioxide. I've included some subscripts here so you can see some ideas of which state they are in. Carbon dioxide being a gas here with the smaller subscripts. Cl2O7, a liquid. CBr4 is a solid. Okay, and again, there's no hard and fast rule. It's just a guideline to help you. This is the opposite case where I've given you the name and asked you to write the formula. Diphosphorus tetraoxide, so diphosphorus would be P2, tetraoxide O4. Tetraiodine, I4, septaoxide O7. Sulfur tetrafluoride, SF4. Nitrogen trioxide, NO3. And phosphorus trifluoride is PF3. Some examples here just have a common name, so they don't use the rules. They just have a common name. So for example, water and methane. Another example is the gas NH3, which is ammonium. So some of them have just been around for a long time and they have a common name rather than using this system. This concludes the section on molecular compounds. The next mini lesson is on acids, naming and writing formulas. So acids are compounds that give off hydrogen ions when they're dissolved in water. So as such, they have to contain the element hydrogen. So there'll be two places where you'll see that hydrogen. Either, most commonly, it'll be the first symbol on the left-hand side of the formula, or you could see COOH on the right. These are weaker acids. So for example, HCl is hydrochloric acid, or CH3COOH. So those are the two places where you will see it to help give you a clue that you're dealing with an acid. There is a naming system, and it's actually the anion that we use to determine the name. There is a table in your data booklet. It's on the second page of your data booklet, and it's called Method for Naming Acids. Please have that in front of you when you are going through this mini lesson, because it will help you to make some connections, and I will be talking about that table. You do not need to memorize these rules. Because you will have the data booklet, so you will have this table, you will be able to use it to help you name acids. So you don't need to memorize this, but just make sure that you're familiar with how to use the table. If the anion attached to hydrogen ends in IDE, so it has the ending IDE, and that's what you're looking at here, you put the prefix hydro in front of the name, you use the root of the word, and then you change the IDE ending to an ic acid ending. So for example, if we had HCl, you look at the anion, which is Cl, it is chloride. Chloride ends in IDE. So you use the first row of the table, and it tells you exactly how to do it. And so it becomes hydro as the first part, then the root of the name, which is chlor, and then ic acid. Another example, H2S. So you look at the anion, which is sulfide. Sulfide ends in IDE. So you would use the first row of your table, and in the table it tells you exactly how to do it. Again, hydro is the first part of the name of the acid. Then you use the root of the word, and then ic acid at the end. So it's hydrosulfuric acid. That is the first example, okay? Second is that the acid could end in, or the anion, I should say, could end in ATE, or it could end in ITE. If it ends in ATE, the acid becomes ic acid. So for example, if you had HNO3, NO3 on your polyatomic ion table is nitrate. Nitrate ends in ATE. So when we go to name it, it becomes nitric acid. You don't use hydro in front. That's only for when you're naming acid where the anion ends in IDE. If it names in ATE, you don't put the hydro in front. You just name it as nitric acid. And you can look in the second row of your table, and it gives you, shows you how to do that, and it gives you an example. The example they give you is H3PO4, which is hydrogen phosphate. Phosphate ends in ATE, so when you go to name it as an acid, it becomes phosphoric acid. Okay, so that is the second example. The third type of acid is something that has an ITE ending. When you go to name it as an acid, it becomes us acid. So for example, if you had HNO2, again, you look at the anion, NO2 is nitrite. Nitrite ends in ITE, so when you go to name it as an acid, it becomes nitrous acid. Okay, the example in your data booklet is hydrogen phosphite, H3PO3. Phosphite ends in ITE, so it becomes phosphorus acid. Okay, let's try some of these together. So again, you see that each one of these, the H is the first letter here in the formula, so that's a clue that you're dealing with an acid. Acids are also always aqueous, so it has AQ as the state. So that can help you as well. Okay, so let's look at some of these. The first thing we would do when we're presented with the formula HF, F is fluoride. Fluoride ends in IDE, so we use the first row of the table, and it becomes hydro, and then the root of the word fluoric acid. Okay, that is using the first row of the table. That's the first type. Second, H3P. So P is off of your periodic table. It is phosphide. So again, you're using the first row of the table, same as the first one here, hydro, the root of the word, phosphoric acid. Now the next one, H2SO4, you would look up SO4, it's in your polyatomic ion table, and it is sulfate. Sulfate ends in ATE, so you use the second row of your table. Again, you don't put hydro in front, it just becomes the root of the word, sulfur, and then you just put ic acid, so it becomes sulfuric acid. The next example, you would look at the SO3 here. SO3 is sulfite. Sulfite ends in ITE, so you keep the root of the word, and then it becomes sulfurous acid. This is the third row of your table. The next one, HCN. CN is cyanide. Cyanide ends in IDE. So it's just like the first two examples up here, hydro, and then the root of the word, ic acid. So it becomes hydrocyanic acid. If you are not understanding how to do this, be sure and see a teacher and we can explain it to you as well. Writing formulas, the name will tell you the anion. You use the same rules as what we were doing before for naming ionic compounds. You make sure the charges cancel each other out. And then you just work backward with what we've been doing right now, and you use the table to assist you. So if it starts with hydro, then the ending would be an IDE ending. If there's no hydro, it's a polyatomic ion. An ic ending comes from ATE, and an OUS ending comes from the anion having an ITE ending. So let's try some examples together. Okay, so hydroiodic acid. So we would look here, we would see hydro, then the root of the word, ic acid. We would go to our data booklet, and that would be from the first row of the table, which means that when it was named as an ion, it had to have an IDE ending. Okay, so it becomes hydrogen iodide, so HI. Okay. The next one, acetic acid. There's no hydro in front of it, so it's just acetic acid. That is the second row of the table, which means that it had to have an ATE ending. So that is acetate. Acetate is CH3COO, and this is an example of where the H goes on at the end. The next one here, carbonic acid. Carbonic ends in IC. So when we named it as an ion, again, it had to have an ATE ending. That is, if you look over here, carbonic is the root, so it will become from carbonate. Carbonate is CO3, so it becomes H2CO3. Okay, the reason why it's H2 is because CO3 has a 2 negative charge and hydrogen only has a 1 positive charge, so it's H2CO3. And then the last one, hydrobromic acid here. Okay, hydro, then the root of the word, ic acid, so that is from the first row of our table. So this means when you name the ion, it had to end in an IDE ending, so that would be bromide. So it's just HBr. If you're having trouble with this, please make sure that you see a teacher for help. And this is the end of naming and writing formulas for acids.